Okay, guys, here we go. So, our objective for the day is I can solve problems involving scientific notation by using different operations. Okay, guys, I hope you had an awesome weekend. I hope you got some time to do some fun stuff, and I hope that you're excited and ready to come back and get started with something a little bit different today, but kind of the same idea with scientific notation. Okay, so here's kind of the game plan for the week. So, we're going to do scientific notation with operations today, and probably tomorrow as well, or a good chunk of tomorrow. Then we're going to review, and then probably Thursday we're going to take our test. Okay, so it's a pretty short unit this time, and we'll be ready to go from there. Okay, so get that objective down for me. I can solve problems involving scientific notation by using different operations. Okay. All right, then I want you to write down this next part too with a little bit of space in between it. Okay. All right, so back, in elementary school, whatever, all the way through your math, there's certain words that mean different operations, okay? And that's going to be the biggest part of today. Honestly, it's not hard if you just remember which place it goes, what operation that I'm going to be doing. So what are some words that mean addition? How do I know that I'm going to be adding? Well, how do I know I'm going to be adding? You might say that we might use the word sum. Okay, sum is just the answer to an addition problem. A lot of other times we might hear the word combine. Write these for me. Combine. Okay? Or another popular word for addition is total. Those three words are definitely used to talk about addition. All right? Now, what about if I say subtraction? What kind of words are we talking about with subtraction? You might hear the word difference. Okay? You might hear the word decrease. Or maybe deduct. Okay, difference, meaning the answer to a subtraction problem. Decrease, deduct, minus, all of those words are words that we use when we talk about subtracting. Okay? Multiply, we might think of that answer is called a product. Okay? Multiply, times, all of those words can be used to talk about multiplication. All right, and divide, what do we call the answer to a division problem? Quotient, okay? Division is one of the tougher ones, and I want you to make sure that you have these ones down, okay? So you have this one. Write this, goes into. And here's one that might make you think of division or multiplication, but it's actually division. Okay? How many times? Star that one, circle it. Okay? That's probably going to be one of the more important ones, and one of the ones that is more confusing because if I see that word times, I might be thinking multiplication. But it's not. It's actually division. Okay? How many times something goes into something is division. If you need to pause the video right here to get down all those words, go ahead and do that. But I got addition, sum, combine, total, subtract, difference, decrease, deduct, multiply, we got product and times, divide, quotient, goes into, and the tricky one, how many times. Okay? Now, for the rest of the day especially, okay, so I don't know if you guys want to Google, try to find a good online calculator. Maybe you have a calculator. But this is what we're going to do, okay? So this isn't too bad. This is just calculator work. If you have one, I want you to get it out. If you don't, I don't know what to tell you. I'll try to find a good one to put it online for you on our Canvas page, so I'll do that before class today, but just be ready to rock and roll with that, okay? So this is just simple. We're going to go 4.2 times 10 to the 6th plus 2.25 times 10 to the 5th. Now, you could get super complicated with this, and we could change them to standard form and then just add them together, but we're not going to. Okay, so my answer that I got was 4425000. And just for this one, we may not do this very often today, but just to remember how to write it in scientific notation, right, our decimal point would be at the end. We want it to go between the 4 and the 4, so let's count it over. So my new number would be 4.425 times 10 to the 1, 2, 3, 4, 5, 6. Okay? This answer here would work, and this answer here would work. I'd be fine with either one of those. Okay, let's try number 2. 8.5 times 10 to the third power minus 5.3 times 10 to the third power. Okay? Gives us an answer of 3, 2, 0, 0. Once again, if you want to make it into scientific notation, you can, but I'm not going to make you do it. Good with those two? All right, number 3. Okay, watch your parentheses. If I was me, type it in my calculator, I would do it exactly the same way. Parentheses, 1.8 times 10 to the negative 4th. Okay? Make sure you're paying attention to where the big box is and the little box. On your calculator, 6.7 times 10 to the negative 5th. Since I don't have an operation in between there, they're being multiplied, right? Okay? Since I got the parentheses, that can mean multiplication. This answer I may want to write in scientific notation, but here it is. We're going to in a second. Let's see. 7 zeros. 1, 2, 3, 4. There's my answer the calculator gives me, but let's write it in scientific notation one time. Here we go. Let's count it over. It's right there. I want it to go between the 1 and the 2. So my answer is 1.2 times 1, 2, 3, 4, 5, 6, 7, 8. But remember, it's a small number. What's that mean? Negative exponent. Okay, negative exponent. Okay, number 4 is my most important one right here. Okay? Don't miss this because you can't type it in right. This is a tricky one. If I do it on a book, a test, a quiz, whatever, it'll probably just give it to you like this. But if I go back to my orders of operations, if I just type this straight into my calculator, okay, it kind of screws up my answer. So there's 2 different ways that I can do it on my calculator, okay? I have the fraction button that I could use, or I can use parentheses. What I would do is I would use parentheses here. So put parentheses around here, and here, and here, and here. Or make it a fraction. 3.46 times 10 to the 17th. 2 times 10 to the 9th. Okay, I like the fraction button on my calculator, or I like the parentheses too. Okay, so my answer is 1, 7, 3, and 6 zeros. There we go. Okay? Not too bad, I hope. Okay, let's keep going, guys. Okay, we're stepping up a smidge. All right. The table below shows the population of the 3 largest countries in North America. United States, Canada, and Mexico. Find the total population. Okay, if I go back to my words from the beginning of the day, find the total population, where does total come up? Total comes up when I do addition. Okay? So to find my answer, what do you think I would do with these 3? Just find the total. So I'm just going to add all 3 of them together. So I got 3.1 times 10 to the 8th plus 3.38 times 10 to the 7th plus 1.1 times 10 to the 8th. 1 times 10 to the 8th plus 3.38 times 10 to the 7th plus 1.1 times 10 to the 8th. And my answer I get 4, 5, 3, 8, 5 zeros. Okay, there we go. Let's keep going, guys. A couple more. We're almost done. What about using numbers before how many more people live in Mexico than Canada? So just how many more? Okay, if I think about my operation there, we're going to talk about this one. How many more? If I have how many more something, this is subtraction. So we're going to subtract these 2 numbers, okay? So 1.1 times 10 to the 8th minus 3.38 times 10 to the 7th. 1.1 times 10 to the 8th minus 3.38 times 10 to the 7th. Do that. 7, 6, 2. There we go. Hey guys, anytime that I'm working out these problems and you want to pause it, and you want to stop it, and you want to try it yourself, go for it. Okay, I always give you more time than the video actually takes so that you can do that. Okay? All right, 2 more. Here we go. Oh, somebody learn how to type. An adult blue whale can eat 4.0 times 10 to the 7th krill in a day. Okay, krill are just tiny, microscopic, plankton type of looking animals that they eat a ton of. At what rate, at that rate, how many krill can an adult blue whale eat? Jeez, Mr. Schneider, wake it up, buddy. I don't know what I was doing here. Can eat in 3.65 times 2 to the 10th. So, think about this problem, guys. I have something that's happening in 1 day, and I want to figure out how much that'll happen in 2 days. Or if I think about this number, guys, 3.65 times 10 to the 2nd power, what's that number really? Moving twice, right? Move it 2 times. In which way? I go to the right. 1, 2. So what am I really asking? I know that this whale can eat that many krill in 1 day. Now I'm really trying to figure out how many krill that whale will eat in an entire year. So if I know 1 day, I'm going to try to get a total. Then I'm going to do multiplication. Okay? So here we go. I like parentheses. 4.0 times 10 to the 17th, 7th, times 3.65 times 10 to the 2nd power. Multiply that together, guys. Multiply that together. Okay? And my answer when I do that is 1.46 times 10 to the 10th. There we go. Okay? Multiply that together. Last one we're going to do together. I'll let you go on your own. All right. A newborn baby has 2.6 times 10 to the 10 cells. An adult has about 4.94 times 10 to the 13 cells. How many times as many, okay? How many times more? How many times as many does an adult have than a newborn? Okay? So what does that mean? That means that we are going to divide. We are going to divide. So here we go. 4.94 times 10 to the 13th divided by 2.6 times 10 to the 10th. Don't forget your parentheses. And you'll be, okay? We set it up. 4.94 times 10 to the 13th. 2.6 times 10 to the 10th. I get 1,900 as how many times more? Okay? All right. As before, here we go. Here's your 2 problems. I want you to try these on your own. Try these on your own, okay? Pause the video, stop it, and we will talk about it when we get there, okay? Alrighty, guys, we will talk to you soon. Do those on your own, and we will be good to go.